right, so I will stay behind the lecterns. So basically, my key message is that domain-driven design, we still need that for digital transformations, and we need you, if you practice DDD, we need you for digital transformations to save the world from the disasters. Thank you very much. And sorry. So I'm a designer. I still define myself as a deliberate designer, so a passionate developer since a lot of time. My Twitter is Cyrille, and I'm known in Paris for launching this software crafters community in 2011, and also for launching this beautiful company. A lot of my colleagues are there, called Arola, and at Arola we are fan of everything DD, TDD, BDD, DDD, and today we're going to talk about mostly the third one. So my key message today is that domain-driven design was too gentle, basically. Sorry, Eric, it was too gentle. Indeed, domain-driven design, we learn to learn the domain, we learn to massage it, to use these domain-driven design skills from the book to massage the domain and to analyze the domain and reverse engineer it into the business domains. And we build conceptual models from that, of what we built. Put your head into the software. And then all this was great, and it's still great, but it's still too gentle for today. Because now, conceptualize, we should go further. We should conceptualize the domain model as a full-fledged theory, so it's a little more ambitious. And from that, in this theory, we have guiding principles, first principles in this theory, and we have to spot them, and then we can challenge them. That's where it becomes interesting. And by challenging the key principles behind your theory of your domain models, you can suggest changes to the business, to the way the business works. And then we can have benefits to turn these innovations, these new proposals, into digital native businesses. Wow! To embrace digital transformations. Yes! I told you so. Digital transformations again. So I know it's a cheap way to have everybody laugh, but still, that's the real point of the talk, and all I say is dead serious. So why this talk? So I could not find a good outline, so I decided for a list of complaints, and hopefully this will turn into a good outline. All right? So yeah, I'm fed up with the way we are given work as software development teams. Typically, we are given work case by case. One user story, this case. Another user story, this case. Another, and again, even more user stories. A lot of user stories. All special cases of a more general case. And you see the more general case here? It's the one model to rule them all. The general case is called a ribbon and a costume and all the possible combination of both. All right? That's a really ubiquitous language, by the way, of the little kitties, Hello Kitties. And this problem is what I call a human compiler problem. And it's an anti-pattern. We are describing the consequences, the multiple consequences of a domain, of a business problem, as opposed to describing the higher level description of it. Please ask for the general case. Don't accept to be fed case by case little consequences of your domain. Enumerated every consequences is a job for machines. Samir Telmar yesterday told us about these kind of things. So some things are good for people, some are good for machines. Enumerating consequences, especially in a Cartesian product like this, but in all other cases as well, is not a job for us. It's a job for machines, compilers, and all these things. So why do people give us these consequences instead of the real problem? Probably something like solution envy. Everybody wants to solve the problem, including business people, and they think that to be solved, it has to be derived enough into more cases. Another thing is probably the lack of trust. Developers would not be able to understand the full subtleties of the domain. Wow. So basically what they want is something like that. Business rules for dummies, one step at a time, idiot-proof, perfect for developers. Okay, I'm caricaturing a little bit, but so at this point, I want to introduce some theory that I call the waterline. And so first, you've probably heard about this dichotomy from Alistair Cockburn. Alistair Cockburn, we have to quote Alistair Cockburn regularly. He invented a lot of things. And he said, if it's your decision to make, this is what we call design. Otherwise, it is requirements. the line is kind of blurry indeed, and we want it to be as blurry as we can to benefit from it. So the design waterline is the line between the things we can decide on and the things we can't decide on. And basically, the game is to raise it. So typically, the way people specify with developers is quite low, I think, unfortunately. And this ends up, the result is that we have to create a lot of laborious code. And the problem is that the lost opportunity is that the business people, business analysts, product owners, and their colleagues, they don't think at this level. They think at a higher level, and they derive consequences for us, just for us, and that's what they call specifying. And this human compiler thing is, so you understand like me, that's totally unfortunate. We turn from the general to the specific and to the multiple by doing this process. That's what I've shown you. Make sense? Anybody disagrees with this kind of things happening? You see that you see this effect in your companies? And our job, the job of everyone, but ours in particular, is to raise this waterline. We can do it mutually. So basically, by asking questions, you don't have to dumb it down. We can understand by ourselves, directly. And actually, we can. Even in finance, which is reputed to be notoriously complicated, actually, developers can quickly learn a lot and in-depth about finance. So if we can do it together, we raise it together, and that's perfect. But sometimes you have to do it on your own. But this problem I mentioned is more generally is also the problem of solution statement. That, if you are given something that is expressed as a problem, actually, it's probably a solution. And it's our job to reverse engineer and find out, hey, what you are giving me is not a solution. It's not a problem, it's a solution, half-baked solution, and I think we can do a better solution for the implied problem that you are showing. So challenging the expressed needs is also part of our job. How do we do that? We ask questions. We ask powerful questions. And so one of these questions is why, repeatedly. And there are many others. And by the way, in your goodies bag, you have some beer mats like that, which are goodies from my company. And there are 6 of them. And you see, there is one sounds like a solution dressed up as a problem. And in the middle of a meeting or a conversation, you can take it and say, hey. And otherwise is, give me a concrete example. And like that, you have different ways, different facilitation cards to improve the conversation with your business partners. All right. Another thing I'm fed up with is that sometimes we are also guilty of that as developers. We are given work at some level on the waterline, and we even manage to make it even more laborious by coding at an even lower level. And a good example that you can laugh at is the if attack or if bombing. If 1, if 2, if 3, if 4, if 20, if 21, if 22, if 2000. No, if 200. I've seen like 200 and something at one point to convert the VB column names into decimal in VB. It was not pretty. So what's wrong, by the way? What's wrong with enumerating every possible case? We don't usually ask this question to ourselves, but what's wrong? It's too much code, obviously. It's not maintainable, and actually we can't even enumerate all the possible space of possibilities. And, obviously it's not good. So the antidote, the antidote? The antidote to this, if attack, actually we start with if attack when we do TDD. The antidote is your refactoring skills that you practice by practicing test-driven development. And the way we do it is we start at some level on the waterline, and we derive concrete examples, which means we go lower, and from them we use our brains, human brains, to imagine what all these examples, how they could turn into something coherent and something more general. And that's our superpower of developers of today, to be able to spot regularities within an ocean of concrete examples. So some people would say, machine learning is going to do that in your shoes now, but that's another discussion. But anyway, this superpower means we can help even business people do that, because that's our key skill. And so we can be partners in doing this process together. Another thing that I'm fed up with, going further is that business people, domain experts, are not always that much of experts. And we have to do this raising the waterline all by ourselves. And the way they specify here and is there. And the way the business really works is somewhere higher, and actually they don't know. The business expert benefit from it, but it's a tacit knowledge, which means they're not even aware they know this. They cannot express their real skills. They can just express some part of it. And it becomes like a hunt to find out the rest. And again, our job in domain-driven design, typically, that's what we have to do. We have to dream of what it could be, to imagine how the domain could be smarter, propose it to the domain people, and that's my job, typically. And then once you reach an agreement, then you can hopefully raise the waterline and start and work together at a smarter level. All right? And well, thanks to this at the smarter level, everything gets smarter, including the implementation. So some people do that already, and we can find good example of this. One of the good examples comes from Google in the SRE book. You can see this. There are some chapters that are discussing Oxon, a configuration tool to provision data centers. And so the tools works at a much smarter level than what we usually do. Typically, we configure data centers there. And it works, it's optional. We have 4 different levels in these tools, 4 different levels of waterline you can work on. The number is, I want 50 cores in 3 clusters for this service. And at the other end of the layers, the smarter level, if you just want to say, I want to run this service at 5 nines reliability. And the system derives the consequences of this requirement into the consequences, different layers until, so basically that's totally the waterline explain, and the chapter of the book explains clearly some details of that. So this, it comes from Google, and Google is typically developer/engineer culture, and so this kind of process more typically happens when people like you are there. Actually, I think we are the professionals of induction, taking the cases and finding out regularities out of it. So it goes, so we need examples on that. So let's take an example. In many applications, you have configurations of lists, static lists. So team members, workers, assignments, all these kind of things that don't move that often, but still, you need a UI to manage them, and you also need somebody has to manage them as well. So it takes some effort. Also, it's also more effort for us to build more pages to manage that. How would you apply the raising the waterline on that? So we ask questions, and we ask questions, where does this list come from? Why this list? Where does it come from? And the answer almost always is they come from other lists, post-processed. Other lists are things that are more raw in nature, like web fields, spreadsheets that are already there, data already in the DB, and the post-processing is merging, filtering, basically these obvious kind of things. So actually, the static list that we want to input on the screen usually could be derived from bigger lists and some processing. But we would have to find out this. So let's take an example of an insurance company working with brokers selling the insurance contracts to many customers. And as a development team, you are given this piece of requirements. Each insurance broker has a list of contracts they manage, and they call it the portfolio of contract. And they configure it on the list, on a web page, configuring a list, like moving from left to right and these kind of things. So we ask ourselves, where does this list come from? And we do some investigations. We go see how the users are using the screen, for instance, or the previous screens of the legacy system. Turns out they always did searches during the setup. And they search on what? They search by corporates. They search by 1 and 3 and second and a third corporate. Typically, they use 3 corporate. And for each of them, they list all the contracts they have, and they just filter out the VIP contracts. VIP contracts are typically big contracts in billions or something like that. So, yeah, we got it now. Now, what we got? We got a SQL expression of a domain model on this very specific little word. Now we can express this thing, and we can. There's nothing fancy, absolutely nothing fancy. But now my list of contract has become a list of corporate, and the list of contract was in hundreds, and now my list of corporate is in 1, 2, or 3, or 4. Is in one hand of fingers of things. So we already won. At this point, I think I like pedantic words, and I think it's time to introduce a new pedantic word. Actually, a couple of them. In this process, what we found out is that we replaced an extensional list into something intentional. Intentional with an S there, not a T. It has nothing to do with intent. And the definition of these words, this is really useful for our daily jobs. An intentional definition is by defining necessary and sufficient condition. Like, what does it mean to be a bachelor? A bachelor is, the definition is being an unmarried man. In software development, we call this a predicate. You pass it something, and it gives you yes or no. All right? That's intentional. Predicates, it's just the basic intentional. So we know that already. The opposite of it is the extensional, and the extensional definition of a bachelor would be the list, the full list, extensive list of every unmarried man in the world. This one is not convenient, right? And actually, so this we can always replace one with the other, and in developer words, extensional means enumerable. We can enumerate iterator, all these things. And that's another thing I'm fed up with, is that I see a tendency to treat everything as extensional rather than intentional. We have a tendency for extensional very often, everywhere. So, by the way, I'm just putting some random tweet to trying to, as an additional authority argument. I'm not sure it works, but net price and something similar, but static lists. So the heuristic I want you to consider is to consider when you are on something extensional, realize it's extensional, and consider the alternative. Actually, it works both ways. And it can improve the problem. Here, for instance, we started with a portfolio as a list of contracts, and we turn it into something more like a criterion. And by doing that, we are getting closer to the way people think, and we are raising the level of language. And also, we are going from a big list to something very small. So actually, we are still introducing a new extensional, but this one is tiny, so we're already gaining. And we also make it explicit. The concept of VIP becomes explicit as a tag somewhere, or the way you want it to be. All right. So on this thing, problem is solved. But at this point, I'm still fed up because my colleagues will be there and say, "Hey, this modeling trick is nice, okay, but it works there. What about all the other business rules? All the other business rules. All the other business rules, as if there had to be many arbitrary business rules in every domain that you encounter. Like it was supposed to be arbitrary, as if there was this rule that's saying that the world is against us, and there has to be just a bunch of. So it's like seeing the world and seeing your domain models and seeing your business as CRUD, managing data in and out, plus a bunch of if statements on top, like a bunch of fields, data fields, and a bunch of if statements, and that was the way the world is made of. That's a very pessimistic view of the world, indeed. So this point of view is like seeing a domain model as a big bag of business rules. No noise. It doesn't work this way. And you cannot get smarter domain models if you believe the world is mostly arbitrary in the first place. So I'm not tricking you into believing that the world is totally irregular either. But there are many irregularities in the world, and our job is to find them out, to exploit and simplify the way we manage software. If you believe the world is just noise, end of the story. I tend to start with the opposite and then be ready to accept when there is some noise. And also, you have to believe that code can be extremely small and still support a huge variety of behaviors. If you have never seen it, you have to believe it just by faith, because that's unfortunate for many. So domain modeling, as I see it, is a quest to eradicate the arbitrary out of the business rules, indeed. And this idea is nothing new. Peter Naor came with this idea in 1985 on a fantastic paper everybody has to read once. Fantastic, very easy to read, and very contemporary. If you read it, it's totally for today. And so what we are doing in domain-driven design, if you want to picture, what we are doing in domain-driven design is really to consider domain model is not just a data model plus if statements. We really want to build a domain model as a theory. And what does it mean to be a theory? A theory is something that helps us understand, explain, and predict behaviors of things. If you worked in science in the past, or if you know people working in science, it's what we call simulation in science. Having some replica, having a small-scale model of the real thing, simplified, of course, to be useful, but that has real predicting power. So, and a good example of theory are many in science, of course, like quarks. Murray Gell-Mann came up with, he got the Nobel for that, he came up with a model of particles called the quarks. And the quarks, this kind of models, only involves 6 things, the quarks, different perfumes of quarks, flavors of quarks. And so they have little names and little visuals. They can be very nice. And then they compose. And just by composing quarks together, you can recreate all the diversity of atoms, particles like neutron, proton. And there's something more. If you understand the rules, the combination combining these quarks, you can enumerate, even with a computer, every viable combination, and you can predict particles that have never been detected before. And then you can go on a hunt to find them and chase them. That's the way the science is working, actually. And it works exactly the same way in your domain models. If you find out something smarter, you can use it as well to generate possibilities of doing business. Why does it matter? It matters to me a big lot, because a theory is extremely concise, as opposed to all the consequences of the theory that are extensive. I like to draw it like that. So by going higher on the theory level, we also reduce the surface of what we have to think about and what we have to code. You know, the finite set of quarks, only 6 of them, and you have hundreds of possible particles. And so the game, coming back to the waterline, the game is putting the waterline on top of this is to raise it and going from a lot of code to a more concise domain model and much reduced surface of code. Whew. So this theory actually is the golden triangle at the top of that we are looking after. And once we got this little theory, in Java, a theory would be a couple of classes collaborating very closely and describing the surface of all your cases in your Cucumber scenarios. That's just what we're talking about, right? So this theory is great, and of course, every management, every line of business system, the domains are not regular, not 100%. They are messy. That's the way. That's the word for them. We have messy domains. So regularities can deal with most everything except some residual mess, and you have to expect some residual mess. And Eric Evans talked about that at DDD Europe 2 years ago. He was talking about the spill zone pattern, and that's the place where you put everything that could not fit into your theory, into your proper, clean domain model. And you have to make it explicit with a name like case we haven't figured out yet, something like that. And you put there you put all the if statements that you can't make sense of them yet. And hopefully, at some point, if you are smarter, they may move to the smarter place once you have the breakthrough. So the way I see it is just like circuit breaker, but for design. You see, that's the place where you, when it doesn't work, go there. But still, at this point, we win. We have a very concise theory taking care of pretty much everything, plus the mess. And at this point, it becomes tractable. We have small, and small is better for humans. And small means testable as well. We can test them. And small means more maintainable too. And there's one more effect. Small means challengeable. So we'll come back to that. Just in the meantime, I have to be fair and to be honest. I have to to introduce one more thing, because becoming smarter, it takes some prerequisites, like you cannot find out all the regularities if you can't have a big picture in your mind at the same time. Let's illustrate that, because the problem is that the discovery path matters. Let's illustrate that. You know, for instance, Alice, 1 year ago, she found out that triangles, there were blue triangles. And then the same Alice found out some triangles could be red. So now she can generalize. And a bit later, she noticed that some could be green. So now her theory is that triangles can be all these 3 colors. But it only happens because it's Alice, Alice, and Alice, and she remembers. Okay? Now imagine it's Claire arrives long after, and she only hears about, she gets a new story that we need to add green triangle somewhere. I have to find a place where it fits, and she has absolutely no idea that there used to be other color triangles somewhere else in the system. So no opportunity to deal with the similarity. Okay? And on another system, Pierre there is very lucky. Somebody made a documentation out of the legacy system, listing every case of every triangle on one chapter. And it's obvious for him that its triangles can have these 3 colors. You see what I mean? The way you discover the diversity of your domain has a huge importance in the opportunities to find the regularities or not. And working one story at a time doesn't help, of course, with that. So if you are lucky enough to start something new, a new ambition in your software, usually you do a story map like that, and you slice the first slice of value, and you go deep into, for instance, selling books. But you know already that you plan to sell DVDs and video on demand and all other things and toys. But the first slice of value for 1 year, we're going to focus on books. And that's not the best thing for diversity, for discovering the diversity of your domain. It could be tempting to go, even in a few hours, to go, what could happen later, and how is it similar or not with what we're going to build right now? And the ideal would be a bit of both, and something like, I propose this name, T-shaped exploration of your probable backlog, like going through the roadmap, even just, so it's speculative work, of course, a little bit, so it's dangerous, but it will also help disposition your head in a smarter way to be smarter over the process. And actually, you know this phenomenon already. If you practice TDD, you know that the ordering of your test cases matters a big time for the solution you end up with. It's particularly obvious on the Roman numeral kata. Different solutions come from just ordering the tests in the different ways. So at this point, you could object, but Cyrille, we are agile. We should be able to change everything anytime, right? In the small, yes, we know that. In the large, I don't know how to do this. At the scale of an application of multiple services, changing anything anytime, it doesn't work to me. It doesn't work for all the teams I've met. It's like in real world, in real applications of a significant size, the first layer of bricks matter most, just like in a building. It will be very hard to change the next layers of brick there once you get there. There are built-in assumptions from the beginning that will restrict what you can reasonably do later. So we still have to learn how to get better at changing our minds, but in practice, that's the way it is right now, unfortunately. It's, for many bad reasons, we can't do it. All right. So at this point, I'm still fed up with one more thing on the way to get smarter domain models, and remember, we want to be smarter for digital transformations, is that even what we take for granted as the domain is the victim of something like that I call the legacy corruption. The problem with domain experts is very often they are not an expert of the domain, they're expert of the way it used to be, as was done in the former legacy system. That's the legacy corruption, and what we consider the domain actually is just the fossilized version of the domain as we used to work with it for a couple of decades. You can spot that with sentences like "we've always done like that," or this kind of horror stories. like you have distorted business concept. Sometimes it's obvious, like here. So this one is made up, but it's very similar of real examples I've met. Like you discover a system, and the tree cycle is configured as a special kind of truck, because the car always has 4 wheels, so it doesn't fit. Cycle and bike and motorcycles have 2 wheels, so it doesn't fit. The only one with a configurable number of wheels is the truck, so tricycle was forced into the system as a special kind of truck. I can't tell you the real examples in finance, but they are very similar, except the jargon is intimidated. Another thing, another corruption of domains is assumptions like this, like since the 2070s, batches tend to fail regularly, and they take a lot of time, so we have to be able to dig inside and to find out where we want to restart. So actually, we need every batch to go from data and immediately create a lot of data that we can inspect, and then the next batch takes them and again. So actually, we have data everywhere. These kind of things, they tend to shape the domains for bad reasons, for actually historical reasons, which eventually turn out to be irrelevant reasons for today. So if we do this work of finding out smarter theory as a domain model plus the residual mess, the legacy corruption tends to be more on the residual side, which makes it more easy to spot. That's a good thing. And so that's good news. And good news, we're going to smile with a kitten, right? This was already very intensive, so I need to put a kitten at some point and relax a little bit. You can smile too. That's the time you have to relax your brain before I come back to my rhythm. I'm fed up with one more thing. That is skeuomorphism in domain modeling. Yes, you do, I've done, we all do skeuomorphic domain models. Skeuomorphic is a terrific word, and actually it's something, skeuomorphic is for this. All these examples from iOS mostly, where what do we see? We see user interface on the computer that look like things that had nothing to do with the computer, like the bookshelf, the mic from the past. This looks like a button, but actually it's not a button, it's a flat screen. And skeuomorphic means it's all about the preservation of the familiar through technological changes. So they look familiar, even though the technology is totally different. That's the idea of skeuomorphism. So skeuomorphism is nothing new. For instance, here, 1,000 years before Christ, these Babylonians, they were building made of stone, but looking like wood, because people were familiar with building in wood at the time. So these wood timbers, these stone timbers look like wood. To be familiar, you probably know that the Eiffel Tower as well, these big arcs are not working. They are just to make people less anxious, because at the time they were used to arcs everywhere, and actually they are non-functional at all. So these kind of things are skeuomorphism, and skeuomorphism is good for a time, because they help everyone evolve through technological changes. But at some point we have to learn getting rid of them. Once they have done their job, it's time to rid of skeuomorphism. And that's precisely what we are starting to observe in many companies. They've been through a lot of software changes, going from manual labor to software, and now is the time to get rid of this skeuomorphism that you have in your applications. So this thing happened in manufacturing as well, and what happened in your companies, in your customers, in my customers, this path-dependent evolution, and it happened just like in manufacturing, just like long ago in manufacturing, you had mass production with a lot of people working together, kind of chaotically, and Mr. Taylor came up with mass production and the assembly line. Big invention, so big assembly line. Now we have this factory line, and we invented the conveyor belt. Perfect. Everything's better now. And a couple of decades later, robots. So now we replace a worker with the first robot. What do? We replace the most labor-intensive task with a robot. And we have a quick win, a huge win. Everybody's happy, and then let's do it again. Introduce the second most labor-intensive task with another robot. And again, until you end up with an assembly line just of robots. Is it the optimal possibility that we have on an assembly on a factory plant to have just a line of robots collaborating together like that? This sounds like a problem of the sum of historically dependent local optimizations may not be the same as starting from scratch and defining what would be the global optimum for this system. Actually, we can do better on manufacturing. And it goes by the name right now of some things like digital fabbing, digital native fabbing, and using like laser cutter, versatile robots, all this. And this totally turns the assumptions around in manufacturing. And for instance, I know it because my brother is in the business. He created a company, his manufacturer of cars, basically, this kind of cars. And they are naturally designed for laser cutting using metal, and for a few versatile robots now, and that's the way they are built. And it has very little to do with traditional manufacturing process. And what are the benefits? The benefit is that you can have very short series of cars, and you can also have mass customization, things that big manufacturers are still dreaming of. And talking with him, sounds like we are in a very similar situations in most companies, banks, big e-commerce, etc. Right now is the opportunity to review the full process and to find out that instead of improving locally, maybe we can improve more globally. So getting smarter, etc. And we are talking about theory, domain models. Domain models have been built on top of principles. That's the smartest of all the domain models. First principles, this was the initial name of this talk, by the way, focusing on first principles. So first principles is all about finding the little things that you can't dig deeper than that. And that's this theory behind thinking from first principles is going down to the atoms of things, and then you can recombine them, or you can change something and recombine differently. So deconstruct and reconstruct. Basically, that's what Elon Musk is bragging about doing for a couple of years now, and that's what he says are the roots of his huge success. I'm not a fan of Elon at all, but I'm a fan of the thinking that principles that we can challenge, I'm a fan of that. Actually, Einstein did it before. He questions very, very, very narrow assumptions, very central, very deep assumptions that time and space were absolute, and from this point, nothing was like before. It has nothing to do at this point with continuous improvement. It's changing one very, very underlying assumption and changing everything else. And when designing software, if you can find some theory of things, then you can also challenge one part of it, deconstruct, and poof, challenge a little bit, and reconstruct everything. That's the challengeable part of this thing, and this is what can help us build digital native businesses. Wow, buzzwords. An example I've been through recently was the loan approval process workflows in the financing industry, so financing tankers, construction mines, all these big financing things. So they work globally, so they have many workflows, and they are all a bit. So they have a lot of problems, like they are inconsistent, there are some problems in them, they are too sequential, so it's too late, and it's in a competitive environment, it's not good. They take some maintenance. So I want to raise the waterline on them, as we've seen before. So we look at all the examples, and it turns out they are very similar, except that some steps are sometimes there, sometimes not there. And the teams are pretty much always different, the teams having to do the task. So we massage the thing, we investigate, and we find out that they are pretty much all the same indeed. And we find out where the differences come from. The teams, they just come from location, basically, plus delegation mechanism. Like if some contract is small enough, of course you don't ask the VP or the CEO to sign himself. You delegate to or herself. You delegate to someone lower in the hierarchy. And if two teams have two steps to do, but you can merge them into one bigger step, something like that. So actually, there's a complete logic behind the things. Delegation and client coverage globally explain pretty much all the differences between all the workflows. So now what we had a virtual business analyst that we can program that can give us, on the fly, the workflow for a particular case. Wow! That's the opposite of the human compiler, you know? we compile the typical job of a business analyst, or the dumb part of the job anyway. So that's what illustrated on the waterline. We propose together, we explain, we talk, we propose things, we agree, and then we raise the waterline and work at this new level. But it was just the beginning. What does the workflow try to optimize for? And we found out things like that the workflow tends to have the most likely to fail steps earlier, not to disturb people for nothing later. And depending on the people, you disturb the most senior people later. So you start by disturbing clerks and junior roles. All right, can we code that into software? Obviously, yes. Actually, we have a code word for that. It's called sorting. Okay, very complicated thing. and actually, one part of this sorting, also in a workflow, sometimes we have a step that depends on another, but it's more like the exception than the norm. But even for that, you know, this topological sorting is the solution to that. If you can define the dependencies, you declare them, and the tool can, the algorithm of topological sorting, which is not very complicated, can find out one or many possible combinations on the way to go through the workflows. So we call it sorting, but from a domain people point of view, it's more like literally expressing optimization, or sometimes even expressing things that have more about human psychology. I'm very good at making everything look better than what they are. So reverse engineering again, that's what we've done, and we raised the waterline again and again. And I think it's not finished. I left the project now, but I think we could go even further, because at some point, it's just like the robots on the manufacturing process. When most of your tasks are getting automated, does it still make sense to go from one CPU to another, to another, to another, as a sequence that takes a couple of weeks? Not sure. I'm not sure. So basically, now I'm mostly in favor of no workflows, killing all the workflows. Actually, so if somebody pushes me too hard, I would say that it means not only workflows, but really I hate workflows now. Because I believe that workflows are just remains, they are reminiscent of the former technology that was pen, paper, and procedures in a company. And this brings to my last point, that there's always an underlying technology, everything. Actually, domain-driven design brings, sometimes it can be understood as a lie. There's a fallacy behind domain-driven design, that is that there would exist an ideal, pure domain, totally agnostic of any technology, but actually there's no such a thing. What we call technology-agnostic domains just mean software-agnostic domains. But what they are deeply grounded into this paradigm of parallel work by many, many clerks with some courier service, mail service going through all of them to bring them pieces of paper, and binders to persist everything. And the previous technology, I don't have a better name than call it bureaucracy. And it was really a technology that made breakthrough and that was able to scale companies at a scale that was not seen before. But right now, it's no longer the best underlying technology, and right now is the time to go further. So we need radical reinvention, and we can also do it, instead of getting smarter and smarter and smarter, we can also do it from first principles, by, for instance, by asking ourselves, what does the workflow try to optimize for at the root of it? And I do believe the answer is like optimizing human people time. Workflow is meant to optimize people time. And the more you automate, the less relevant it is. Make sense? and also a few other examples of first principles in everything credit risk. The first one is for first principles, you are going to give money to people, and you'd like to get it back. So basically, the credit risk from first principles is it balance the risk I'm taking and the guarantees I can have in exchange? And that's it. It's like a balance. And very good UX people understand that, and they propose spontaneously. They propose a UI split in two, and you can see visually you can see the relationship between them. I've seen that already. And this makes for very nice UIs. Payment. What is the first principle behind payment? I do believe that it's just non-repudiation. A good payment subdomain is just meant to be sure that you cannot cancel it after you paid, so that somebody can ship you something or something. So going radically from first principles is a different process than raising the waterline. It's trying to start straight from the top, ignoring the traditions. And so it's more like, what if? What if we didn't know that the cars had to have 4 wheels? What if we didn't know? Or what if things that we held true for centuries were no longer true? So for instance, these people, mostly from Google, they say, what if you could have an engineer every time you instantiate a database? What if you had a database engineer inside a DB tuning your indexes so that they are maximally fast? And of course, they could ask this question before, because now we have machine learning, and this can create crazy. This can give you crazy idea like that. So if you can't implicitly, when you have a DB, the DB implies that you don't have an expert close to it that can create fine-tuned indexes. So what we use generic indexes like binary trees or this kind of generic indexes. But if you have a DB with data inside, you can analyze the distribution of the data, and you can create custom-made indexes. And machine learning can do that. They've done it. So and you can have massive breakthrough, like 2 or 3 times faster indexes. The problem with this approach is not so much a technology or feasibility problem, it's more of a political risk problem. As soon as even if you have the solution, somebody politically has to risk their seat on going with it. And that's the big problem. In big companies anyway. And that's what I mostly know these days. All right, so in closing, it was a dense talk, I know. Just 280 slides, I'm sorry. In closing, I encourage everyone to consider raising the waterline. I encourage you to expect untold regularities. Nobody will tell you they are untold. They are there. As usual, the beginning is starting with test-driven development. Test-driven development is always the basic hygiene of everything. There's a life before and there's a life after. You cannot be the same after TDD. And then practice domain-driven design. Domain design is not outdated at all in the process. But what we are going is just that we are going further. We are doing like domain-driven design plus. Build theories, not just list of business rules. One huge influence for me has been these 2 books. Actually, I think the analysis pattern should be called Domain-Driven Design version 0. That's the first Domain-Driven Design book, actually, the Martin Fowler book. Eric's book is number 2. Learn to and practice to think from first principles so that you can learn to disrupt instead of being disrupted. So that you can embrace digital transformations and bringing your customers and your software into software-augmented businesses. Thank you very much. Do we have time for questions? Do we have time for questions? No time, Sam. See? How many? 1 minute. No questions? Bad sign. Feel free to come to me later if you have questions, or objections, or hate everything you said, or something like that. Thank you very much.